So let's go back and review some of these ideas. So we said the problem to solve with the Singleton design pattern, and that design pattern kind of is the smallest design pattern because in your class diagram it fits directly in the inside the box, right? Inside that Singleton class, we say that. By the way, it's not going to be called Singleton in the real application, right? So this can be called, database connection, right? So we can, we just essentially envision an object that behaves as a singleton, and we design it based on the Singleton design pattern. But in our demo, we just identified that this specific class represented Singleton design pattern, and that's why I chose it to be Singleton. Okay, so control access to resources, right? So you just say, I have one single resource. It can be an image, a video file. It could be like it is indicated on this specific slide, a network connection, and other, really unique. It could be some sort of like security certificate, which maybe you don't want to multiply in multiple classes and in instances of these classes at runtime. You just want to protect a single point of access to that thing. So, and here is the UML diagram. Now, on this slide, we also introduce a piece that looks like a lock. Right, so we say that when we say get instance, we want to take advantage of having a lock. What's going on here is this: is that if you have in multi-threaded multi-user environment, what you can have one user, user 1, and another user 2, right? And they want to use your Singleton. And so these users, right? This is the timeline. So the time goes down this way, runtime. And what happens is that they both call get instance, right? They both say get instance. Both say get instance. And it's possible that if this user runs on one thread of execution, right? We'll indicate it by one color. And this user runs on a different thread of execution, which we can indicate by a different color over here. Essentially, there are three scenarios are possible, right? So scenario, first scenario is that user one creates Singleton, right? So the user 1 basically creates an instance of this object right here. So that's scenario 2, is that user 2 creates that Singleton. That's also possible, because they basically compete, and if it just happens to be that this call is a few microseconds earlier, right? So this guy will create the instance, right? But if it's this one that happens to be running a little bit earlier, then this one will create an instance, right? So it's going to be happening like this, right? But there's also possibility for a third scenario, that when they call in such close proximity over here that they both hit the idea that both see that both will see that the singleton is still not created, and it's possible that when this method getInstance is invoked from two separate threads of execution, that they both hit this condition to be true, that it equals null. Well, guess what's going to happen? At this point, both will say new, and both will execute new. So we have a little bit of a problem over here that we want to be able to solve it with a possibility of a lock. In other words, what we would like to say is that we would like to have some sort of a lock, right? And say that this is a critical section of our code, and we want to say that this equals new lock, and we want to create an object which will protect this section of the code, and guarantee that it can only be accessed by someone who obtains this lock. If we have a competition between multiple threads of execution trying to get the lock, one will succeed and the other one will have to wait. But I'm expecting that if the execution of this constructor is going to take a long time, then we're not introducing a big problem by just, attempting to protect this section of code by, this critical section. Okay? So we also should not forget to basically, I would say, release, right? Release the lock or unlock. And essentially, if we had some sort of protection available like this in the system, this would be great. Because then we could always guarantee that even in multi-threaded environment, we don't have this race condition, so that which adds the possibility, right? So the problem would be here if both create singleton. That basically derails the entire idea of having a singleton object. So in multi-threaded environment, static data member can be seen, the same value, the same initial null value can be seen by both threads of execution. So therefore, we need this protection. We need to tell both threads that you cannot access this section which analyzes the state of instance before you obtain the lock. But we will guarantee that only one of you will be able to obtain the lock at every single time, right? So if we just happen to hit this need to say get instance at the exact same time, what's going to happen is that one of the locks over here will be able to successfully create critical section, and the other one will have to wait. For this, we need some special help from the system library, right? So step number one, what I would like to do with this is that I would like to first add the lock class, right? To my let me just go to my package, and I will say new Java class, and I'm going to name it a lock, and I'm going to say that that's pretty much will create the class, right? And inside this class, what I would like to have is these two things. First of all, public constructor, right, which will obtain the lock, number one, and number two, public void release, which will release the lock and allow other threads to obtain that lock. Okay, so that's the idea. But that's the next level of magic that we need to deal with, right? So we need to somehow come up with an idea of a lock which is capable of protecting us from that erase condition. And of course, we need help from the operating environment. In fact, there are synchronization objects that come from Java library, and we're going to use one of them today.